Hello, everybody. I'm back again with another live stream. I was a little away till now. I haven't practiced this week because uh, I went for a trip. I also had my hair cut. My room is a mess. Still, I need to fix everything. I came back like on Thursday, and after that I didn't get any time to do anything. But yeah, finally I'm back. So uh, now we can start again our coding journey. I'm really excited for like using my brain because I haven't used it since a while. So I want to use my brain. Okay, I need that secret reward. Uh, is it you wanna say? Okay, give me that 10 lead go. Hey, what's that chicken? No, your this is premium. Are they offering any better? This plan saves 60% in comparison to the monthly plan. Okay, cool. So let's start again. Let's try to code. Um, I what I'll do right now is I will give the contest, last weekly contest, and then we'll jump to Codeforces questions. So that'll actually give me a brief idea about the data structures algorithm also, and then we can jump to the mathematical part. So let's start without wasting our time. Let's see what all these questions holds. Okay, it's like nowadays I'm seeing most of the questions are, the first question is normal and the second question is a follow up for the first question. Okay. Okay, where is my, okay, here it goes. Cool. So you are given an integer array nums. Okay, uh, start by selecting the starting position current such that nums of current is equals to 0. Okay, the value should be 0 and I need to start with the starting position. Means I need to start with a 0 value and choose a movement direction of either left or right. After that you repeat the following process. If current is out of range 0 to n minus 1, this process ends. Okay, if current value is 0, move in the current direction by incrementing current if you are moving right, or decrementing current if you are moving left. Okay. Else if the value is greater than 0, decrement nums of current by 1. Reverse the movement direction, left becomes right and vice versa. Take a step in your new direction. A selection of the initial position current and the movement direction is considered valid if every element in the nums becomes 0 by the end of the process. Return the number of possible valid selections. Okay, I need to return number of possible valid selections. So if I select this 0, I can like select any of the direction. I can go right, I can go left. Fine. So I need to start with 0. If there is no 0, okay, it is saying that there will be at least one element with nums of I is equals to 0. Then it's fine. So okay, by simulating things, let's see. The only possible valid selection are the following: choose current is equals to 3 and movement direction to left. Okay, I have selected this and movement direction is my left. I reduced this, I moved to back to this position, then I went to this. I okay, so something that I'm getting, like whenever values are greater than 0 it will reverse the direction. So I need the pre-sum and the post-sum kind of thing. So like the pre-sum and the post-sum should be at least should be same. I need to find a position where pre-sum and post-sum are same. So it doesn't matter where whichever movement I do, either left or I do right movement, it will not affect my answer. So it will be like a pre-sum and the post-sum if they are same. So at this position, what is the pre-sum? It's 3 and post-sum is also 3. So this is the position where I can do the stuff, and if I'm at this position I won't be able to do the stuff. So if I'm at this position I have like two options always. If either I go to right, either I go left. So I can select any of the movement. 4 5 6 7 8 9, pre-sum is 9, 4 plus 1, that is 5. No, so this is not also correct. So I need to check like every time if pre-sum and post-sum are same, we'll do what we'll say, yes, I can do it, and that'll increase my count to 2 plus 2 because I can go in either of the direction. Doesn't matter. Okay. Okay, so instead of values, okay, it's very small. So so right pre-sum plus is equals to, okay, numbers of I. Okay. Okay, so this is my left pre-sum. Perfect. Now I will do what? I'll start iterating from start, and I'll check for every position. If nums of I is equals to 0, if it is 0, then if it is 0 and n, obviously if I'm at current position I need to reduce that value from right pre-sum. So right pre-sum minus is equals to nums of I, and if and this, and left pre-sum is equals to my right pre-sum, then like count plus is equals to 2, and then my left pre-sum will be added with I need to declare count. Okay, so for first it is 2 0, submit it. Oh, okay. Okay, it can be like odd. Hmm. Okay. Okay. I I calculated something wrong. 16, 13, 10. This is my like option. I only see like if the value is greater than. So I need to decrement it. Reverse direction. Text step and then. So 60, 10, 20, 30. This is 39. And what's on the right? 16, 21 plus 8. 21 plus 8, 29 plus 7. Okay, there should be. Uh, okay, okay, okay. 8 plus so like what was the value? 16 plus 7, 21 plus 8, 29 plus 7 is 36. 36 is here, and 39 is here. So if I start from like in the left direction, I would like this will reduce by 38. This is still 36, right? 10 plus 6 plus 7 plus 8 plus 7. Oh, it's 38. Wow, 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 wow. How I'm even calculating that? 16. Sorry, 4, 5, 6, 7. 23 plus 8. So it's 38. So if I start from left direction, so there will be like one more condition. If like both are same, I can start from any of the direction. If not, if left pre-sum value is 1 greater than right pre-sum, then I can start with left. Else okay, okay, I need to check this also. Else if nums of I is equals to 0, what the hell, I should have like got the intuition. Value plus 1 is equals to right pre-sum, or this is so bad. I should have or left pre-sum is equals to right pre-sum plus 1. If any of these condition satisfies, okay, at the same time both can be true. No, it's not possible. So only one will be true. So count plus is equals to 1 in this case. Oh, it's 3. Okay. Okay. Fine. You are given an integer array nums of length n and a 2D array queries where queries I is equals to LIRI. Okay. Queries where query of I is equals to LIRI. For each query, select a subset of indices within the range Li and Ri in nums. Decrement the values at the selected indices by 1. Array where all the elements are equal to 0. A 0 array is an array where all. Return true if it is possible to transform nums into a 0 array after processing all the queries sequentially, otherwise return false. So like from 0 to 2, the values of these indices by 1. Select the subset of indices as 0, 2 and decrement the values of at these indices by the array will become I didn't get it. It's saying 0 to 2, right? I have this nums array, so I already have a 0 that will be reduced. Okay, so it's saying like select a subset from here. So I'll select this, select the subsets of the indices as 0, 2. It's not 0 to 2. Let me check this. Okay, let's check this example. It's saying 4, 3, 2, 1, 1, 3 and 0, 2, right? So we have 4, 3, 2, 1. So from 0, 1, 2, 3, it'll always be, the queries will always be in range, right? Possibly. So 1, 2, 3, select the subset of indices as 1, 2 and 3 and decrement the values at these indices. So 1, 2 and 3, if I decrement the values will be like 4, 2, 1, 0. That's fine. For 0 to 2, select the subset of indices as 0, 1 and 2 and decrement the values of these indices by 1. So 3, 1 and 0. It's not possible, right? So I can I have given a range. I can select the subset, multiple subsets inside this range. This is what he's talking about, right? Select a subset of indices within the range. Select a subset of indices. Okay. Oh, okay. Like the question is somewhat. I have been given for this query 0, 1 and 2. These are the three values given to me, right? Now what I need to do is select a subset from these values and reduce all those values. So I will always like kind of always try to reduce all the positive values in this array. If there is a zero, I should not like reduce the value, right? So if it is 101, I create another array which is 0 1 and 2. Like what is the follow for this? Okay, now okay, there's one more query of val I. And there, here it is like decrement by one indices, and here it will be okay. There is like a little change to that. Now what we can do over here? What we can select okay, let's reduce this value and add a value here. So I know that from here to here values are changing. So if I do a pre-sum 1 minus 1 minus 1 minus 1 and 0. So like I can reduce this. It's possible to reduce this to -1, right? Now 0, I can do like lots of operation over here. There's one thing so what if there was a value like 2 over here? We could have only reduced it by maximum one time, right? But what if like if I could have reduced it like three times, so I can do it. I could have reduced it twice and said don't apply the operation for the third time, isn't it? So this will boil down to like 0, and don't select this subset next time. So this negative value like always should be at least equal to the value or greater than the value. This pre-sum is what I am guessing should be the answer. For the second query, if I see 4, 3, 2 and 1, I'll have this array 0, 1, 2, 3 and 4. So first is like from 1 to 3, 1 I reduced, here I increased. From 0 to 2 I reduced, here I increased over here, correct? What's the pre-sum? It's -1, -2, -2, -1 and 0, right? Now the absolute value, like this is like always going to be like a negative value. So this absolute of this and this should be like, this should be greater than absolute value of this should be greater than absolute value of this. uh, okay, right. If it is like possible, then move it, but if it is not, like, then skip it. So maybe this is like mostly feels like a line sweep algorithm, and until now I can see like it should work. But if it is like in any way, if it is creating a problem, like, we can line sweep start size plus 1 and everything initialized with a 0. Let me take okay, let's iterate over the for each query. For each query I need to apply on line sweep of queries queries of I of 0 minus minus, and line sweep queries of I of 1 plus 1 plus plus. Lesser than and equals to n plus plus I. Let's start from 1, like I don't have to start from 0. So line sweep of I is equals to line sweep of I minus 1 plus sweep of I. So this will do the pre-sum operation. Now I need to do like now absolute value of if absolute value of line sweep of I is like lesser than nums of I, so this is the position I'll return it false, else I'll return true. So first it is true, second it is false. Okay, great. So this was accepted. This is now the second part. The most probably the algorithm will run. Okay. Now the question is a little different. I need to apply operation. Decrement the values at each index in the range. This was like a subset. Select a subset of indices for this. Now here I need to decrement the value at each index in the range LR in nums by at most val I. The amount by which each value is decremented can be chosen independently for each index. Okay. Okay, return the minimum possible non-negative value of k, such that after processing the first k queries in sequence, nums processing the first k queries in sequence, nums becomes a zero array. If no such k exists, return -1. Okay, like I do not have to like do all the operations. Like at each and every operation I need to check. Okay. uh the array given is like 10 to the power 5, so I it's not possible for me to do the direct operation that I did over here. I need to like think of in some kind of other way. Like kind of coming to my mind is like after doing each operation I could do a binary search and check whether, but will that like help me in any way? And at also I have at the most val value that I can reduce, so I can take like lesser value also to reduce it to 0. So like if val is like greater than how many operations are we performing? It is something that how many operations are we performing on that value? Because I cannot select a subset, I need to select the value. Hmm. Okay, let's see. So the first operation is telling me if I have this line sweep. Hmm, is this line sweep going to help me? That is the one I need to check. 0 1 2 3. So from 0 to 2 I can like decrement it maximum by 1. So if I reduce it by 1 over here and add 1 over here, fine. For I is equals to 0, left and right is this, value is this. Decrementing all the values respectively will like hey. It's like 0 1 2 and decrement values at indices 0 1 and 2 by 1 0 1. Okay, so here also that concept stays if the absolute value is greater than this. So it's kind of a subset only, because I'll always have like 0. Okay, and because if val I is positive always, and also val I is like maximum 5. Queries dot length is 10 to the power 5. Okay, here also queries dot length was 10 to the power 5. L and R are in range. The array will become like 101, and then again it's 0 to 2, reduce it by 1. At this moment, at this point of moment, hmm. So if I, or what if like 0 to 2 is -1, now again 0 to 2, what happens is this will become -2 and this will become like +2. So this is the position. I do not have to go with the like the third query, right? I operated on the first query. I got uh, -1 and +1. Now what I can extract from here? Like, is it going to be a line shape algorithm? There's like maximum I can do, like for every query I need to check, is it possible or not? For every query I need to check, is it possible to reduce everything to 0 or not? And for reducing, like this is the same thing that I can do, right? I iterate over each of the value and check. So for every query, if I'm running this for loop, it'll like give me DLE, because the range is like 10 to the power 5. What can we think of? Like, is it giving me like I applied this operation, -1 -1 -1, and here it will be like 0. After every operation I'm checking the same logic, with the same logic that I did previously. Is it possible or not? That will give me O of n square time complexity, correct? And now I need to reduce the time complexity. Okay, so what was happening is, like, every time I cannot run this query, I cannot iterate over the array and do that stuff. Like 0 to 2, reduce a value from 0 to 2. If it is like 0, don't do anything. We cannot like apply the third operation. If we apply the third operation, then I will not be able to know some kind of see, one thing that I know for sure, the maximum value, whatever the maximum value is, that many sums should be there in the queries, at least. So till there, I'm pretty much sure that I will have to go. So like 2 plus 1, 3. 3 is obviously lesser than 4. Okay. But it's not always correct or true to say this. Nice, huh? Can we apply binary search over here? I did one operation 0 to 2. Now, what will I search using binary search? What will I search? Like, is it possible to reduce all the values to 0? How much time do I have? I still have some time. I need to think in. I need what? Every pre-sum value should be greater than equal to its value, right? And what if I do it in reverse way? Do all the operation, do the pre-sum. If any of the values is like absolute value is lesser than that, if not, it will be something like, what if I remove this value from 1 to 1? Is it going to change my answer? Okay, let's try to think in this direction. See, we have this. We applied the second operation, and we applied the third operation. Now my total pre-sum would look something like this: -2, -3, -2, and 0. I have this. Now every value is like a checked. If this would have been like 3, then also we would have been able to reduce it to 0. Okay. Now if this would have been 2 also, it would have worked. Right. So if I update it with 2, this would have worked. Interesting, huh? Okay, I reduced this 1 1. Is it affecting my answer? So like +1 +1. +1 and like -1. Plus I am adding +1 and -1 here, right? So +1 will like give me -2, -1 will give me and this is like wrong. Why it's -3, -2, -4. No, what is happening? Okay. What if thinking like opposite direction? Opposite direction, like if I start from back, how many indexes we can go and switch? We make everything 0, not equals to 0. What can we think of here? Like out of my possibility, maybe I'll take some hint. Okay, like we can apply binary search, but how? Okay, okay. I was thinking of going in a binary search approach, uh, but how are we applying binary search here? That is a question. A good, a good question. Right? We have this 202. Like I applied this 0 to 2. Okay, we have this 0 to 2. These types of questions are generally solved by binary search. From 0, if I do like plus 1 and 2, 3, if I do like minus 1. Do we even like require this? And do the binary search operation. Now binary search will do what? From range like 0 to 2. How are we applying the binary search here? That is the question. Utilize a difference array to optimize the processing of queries. We have this array, we have this queries. Anything that is getting like utilize the difference array to reduce to optimize the processing of queries. Okay. Gated line sweep. We can use the line sweep approach to check for zero arrays in O of k plus n, where k is the number of queries, n is the number of elements in nums. There is something, why value is 5. I don't know. Okay, what if we sort based on start position? And until and unless this value becomes 0, I will have to like move the this pointer. If this becomes 0, I've already applied these operations, so that will be pre-computed and will go to this position. Oh, okay. A nice one, yaar. Do sort. Let's do. No, we cannot sort, right? The queries are in order. Correct. Mm, hmm. Hmm. We can think in that way. Why not? Why not? We can think in that way. But I need to know the binary search approach too. Okay. 0 to 1, 1, 1, and 3. Now we have a line C. 0, 1, 2, 3. I have this 0 to 2. So my like this pointer is here. I need to make this value for sure negative. For sure at least 2. So 0 to 2, 1. So do -1 here and +1 here, right? This value is still not. I'll move to the next query. I'll do again operation -2 and +2. Now these are equals, right? So what I will do is uh, I'll move my pointer here, both pointers here. This will be like pre-computed -2 because there was no value, so it's pre-computed. It's greater, so I'll move my pointer here, this pointer here, and this will be like pre-computed -2. So this value will like my array will end and it will remain whatever at what position. Oh, okay. 4, 3, 2, 1. So 1, 3, and 2. 0, 2 and 1. Zero, 1, 2, 3 and 4. Okay, so there will be a line sweep, nums and queries. Everything will be initiated with 0. I'll have pointers. Pointer I for nums. So I'll make it like mark it as 0. Uh, queries. For queries, I'll take j as 0. Okay. No. Nums. For queries, L for nums. Capital. And I is equals to 0. I is lesser than n plus plus I. Right. Now until and unless this current value becomes current absolute value becomes equal to or greater than, I will move. I will apply my queries. While this current query, so I'll have while current line sweep of I absolute value of this, while absolute value of line sweep of I is lesser than nums of I, and while q is lesser than m, I'll do what? I'll do the operations. So for first operation, what I will do is line sweep of queries of q of and then q is lesser than m. So until unless this line sweep of queries of q of I, what I will do is I of 0 will be like minus minus, not minus minus, but minus is equals to queries of q of 0, 1 and 2. Same thing, line sweep of queries of q of 1 plus 1 plus is equals to queries of q of 2, and my q will increase. Now if q is equals to m, I'll return -1, else I will do what, my L will increase. And at last I'll return q plus and
What's the timing, bro? You're not using headphone?
I can apply two conditions. Is it something like comma separated? I forgot how to apply two conditions. Expected semicolon for statement. Okay, let me do what, apply a while loop while L is lesser than n. L plus plus. Line sweep of I. There is no I, bro. Everywhere it's L. Zero, 1, 2, 3, and 4. I didn't do the pre-sum operation. Line. Okay, I'm going to the next index, right? So whatever value we have currently, that will be added to the next index. So L is increased. Line sweep of L is equals to line sweep of L plus line sweep of L minus 1. that'll increase. Okay, what if we had this value as 3? 0, 1, 2, 3. For the second, make this value as 3. So 1, 2, 3, reduce everyone as from 2. Hey, it's possible, right? And there's some silly mistake. There's something silly mistake. 3, 3, 2, 1. Okay, so the first query says my my Q pointer is here and my left is here until and unless the absolute value of line sweep L 3 4 absolute value of line sweep L while Q is lesser than M and absolute value of line sweep of L is lesser than nums of L, तब तक हम चलेंगे. So what we are doing is line sweep of Q of 0, that is 1, is reduced by -2, and 3 plus 1 4 is increased by +2. Correct. Still I'm not able to make this as correct. Now 0 to 2, reduce it by this is not possible. If I do change it to 0 to 3, then it's possible. And 0, if I do 0 to 1 also, then also it should be possible, right? Okay, correct. Okay, what's wrong? This is very small, I can debug it. So first query, my Q pointer is here. What I'm doing, I have my line sweep as this 0, 1 and 2. From 0 to 1, everything is 4. Now first of all, this value will not, my L pointer is here, my L pointer we checked, Q is lesser than M, that's fine. And line sweep of L absolute value is lesser than nums of L. It's not, so this will not run. If Q reaches this and this, else what I'm doing is I'm incrementing my incrementing my left pointer. So if I increment my left pointer, and this will be 0, but if we do something like this, 0 to 1, do this -4 operation, if I would have done this, is greater. Now this will fail. Huh. There is something else to it. This logic will fail, like doing operation one by one and finding. I even cannot sort the key queries, right? Because if we sort the queries, it will change. Mm, why didn't came to my mind? This could be possible. One of what what else can be done? Okay, I think I should see the approach. We can use the line sweep approach to check for zero array in O of k plus n. Okay, where k is the number of queries, n is the number of elements and nums. We combine this with binary search to find the smallest k. The time complexity is O of log m plus n, where m is the number of queries. We can avoid binary search by gating line shape and applying remaining queries till the current element becomes 0. Thus the second solution below works as O of m plus n. Okay, I need to learn both binary search and gated line sweep. First I'll try with the gated line sweep. What I did is I declared a line sweep. Fine, this is what I'm doing. I declared a line sweep for n plus 1 size, I have two pointers I and j. I did this. Okay, fine, let's see the logic. For j is lesser than, okay, j is for queries, right? And current, okay, current is a presum, and current value is lesser than nums of I. So if this is the case, this is what I'm doing. Like if this is the case, if q of j1 is greater than equals to I, what is this gated? What's this logic? What's this logic? If q of j of 1 is greater than equals to my I, like if it is greater than my current index, or equal to my current index, if q of j of 0 is lesser than or equals to my current index. So what I will do is current plus is equals to q of j of 2. If q of j of 0 is less, is not, if it is like going beyond, then line of q of j of 0 plus, okay, it's going a little confusing. Okay, I'm getting what the intuition here is, but somewhat he is like doing the pre-sum every time if the value if current index if query's index is lesser than current index. So he's just computing the pre-sum from there, and if it is greater uh, uh, like let's see what this binary search holds. Binary search is saying, okay, let's try from here to here these values, whether it is possible or not. Oh, okay. Shit. How can, like, I was thinking of in some other direction. I could have thought of this binary search approach. Like, let's try applying these many operations. Now, is it possible? Can be checked in often. If not possible, I need to take more values. So I'll move my pointer. So it will be like n log n complexity. So is zero array possible by doing this? If possible, do this, else do this. And if left is lesser than left, else return -1. Yes, binary search. I had these intuitions, like I was very close. All the questions are like moreover same. The approach is always going to be like very similar. The only thing changes is like how to apply it. Let's try the binary search. And left is 0, right is now while left is lesser than equal. It is equals to left plus right. Okay, if is possible, if if it is giving me if possible is true, so I'll try to reduce. So right is equals to, I can like even keep an answer, but I don't want that. Right is equals to mid, else left is equals to, now if left is lesser than or equals to q u e or e s queries dot size, then return l, else return -1. Now is possible, I need to check is possible. I have this nums, I have this queries array, I have this mid, means I need to go till mid queries and check. So I can use these operations. What I'm doing is I'm passing nums, I'm taking queries, I'm passing nums, I'm taking queries, and then m, so m will not update here. I'm only going till m, doing the line sweep. Take, no, return init. Why? So I declared a line sweep of n size. I'm going till m queries. Oh, and I'm doing something wrong. Like minus is equals to queries of I of 2. I for the second test case, why it is -1. 0 2 3 0 1 2 3 and 0 2 1 1. It's possible, right? It's possible. Why -1? For this it is 3. This should not be the case. It's like this is the index. Till here I need to go. Hmm. Correct. I need to answer it mid +1 2 2 3. Still wrong. Why? Expected 0. Means if input is 0, okay. Hey, come on. 2 2 3 is 1. Why 1? I found a mid. I'm saying till here. If it is possible, reduce it. If like the input is 0, if like the input is 0, even if I do this, that's the binary search trick. But okay, let me try some binary search thing. Return L is lesser than nums dot. If this is the case, return L, else return -1. What's daily? Really? Okay, nice. I This was like, mm, I would say good question, but I didn't use my brain. That's it. If I would have used a binary search brain, simple. It was literally simple question. It was not that difficult. How complex I was thinking shouldn't. Okay, fine, fine, fine. Okay, I'll take a 10 minute of break and I'll be back after 10 minutes and then we can move forward. We'll try Codeforces questions after that. So see you in 10 minutes. I'm back. Okay, let's try this array game. I'm not going to solve this hard level because I think only 34 were accepted. I'm not sure if it's okay. So we were able to solve this, and this. Hopefully, I'll not forget this. Oh, it's like binary search was in my mind, but I don't know what happened. Okay, let's see. So we are given an array A of n positive integers. In one operation, you must pick some. I have a array with 10 positive integers. In one operation, I must pick some I comma j, such that some I and j. I should be greater than equals to 1 and j should be lesser than equals to mod of a. Means array size. That's what he's saying. And append a of I minus a of j to the end of the array a. That is increase n by 1 and set a n to a of I minus a of j. Your task is to minimize and print the minimum value of a after performing k operations. Okay. Okay. Let's load how we are doing it. This is a 1400 rated question. So you are given an array A of n positive integers. Fine. In one operation, you must pick some I and j. Like two values I need to pick. Should be like from 1 to a, and append a of I minus a of j to the end of the a. That is increase n by 1 and set a of n to a of I minus a of j mod of a of I. Your task is to minimize and print the minimum value of a after performing k operations. Minimize and print the minimum value of a. Okay, let's see. Uh, the first line of each test case contains two integers n and k. Okay. The length of the array and the number of operations you should perform. The second line of each test case contains n integers a1, a2, an. A of I1 to 10 to the power 18, the elements of array A. It is guaranteed that the sum of n square overall test cases do not exceed 4 dot 10 to the power 6. Output: for each test case, print a single integer, the smallest possible value of the minimum of array A after performing k operations. Okay, the smallest possible value of minimum of array A after performing k operations. So 5 into 5 is the size of the array and the two operations that I can do. This is the array. The two operations that I can do is like I can take 3 and 1, two smaller values, subtract it, append it. And even I need to append the mod. So it doesn't matter if I and j are, we can like sort the array. It is guaranteed that the sum of n square overall test cases do not exceed 4 into 10 to the power 6. For each test case, print a single integer, the smallest possible value of the minimum. For first, it is outputted as 1. Okay, so 1 minus 3, that is 2, and then 1 and 2, we'll pick 1 and 2. That will be like 1. So 2 in 2 operation, 1 is the minimum value. 6, 7, so like it is going kind of a priority queue approach, where I have this like 4 and 3. So I'll put all the values, I'll pick the two smaller values, subtract it, and whatever value we'll get, we'll push it back to queue. Then we'll take two values again. So it's like basic priority queue. Then pick I is equal to 3 and 4. This will also give me 3. Me 1. Okay. Now there's something not always going to be correct out here. It's like 15 minus 12 will give me also 3. 7 minus 4 will also give me 3. And then third operation will subtract 3 minus 3, which will give me like 0. No. So it's not always we are picking the smallest value. So greedy will not work. What's left then? Just a second. I need we have 4, 7, 12 and 15. If it is like in sorted order, I know that 4, 7 will give me 3. 7 and 12, like 12 minus 7 will give me what? So it's going something like this. So 7 minus 4 will give me 3. 12 minus 7 will give me 5. And 15 minus 12 will give me 3. Again, right? So 3, 3 and 5. Now who's the smallest? 3. Anyone I can take, like either 12, 15 or 4 or 7, append it. So the values will be like 3, 4, 7, 12 and 15. Now the new value added, the position where it will go, the value previous to it and the value next to it, will be subtracted again. Like I'll remove this. I removed this, and I have this 3 minus 4, that is 1. In two operation we did this, but this is not optimal. What else can we think of? had this 3, 3, and 5. If we had like 1, 4, 7, uh, so it will be like 3, 3, 3, and 5. We could have created a like 3 and 4, that will give me 1. 1 and 1, that will give me 0. This could have also been one of the possible way, or 3, or 3, or 0. Interesting, huh? Anything that is coming to your mind, like if it is coming, try to implement it, else wasting time is not an option. How are we optimizing it? What's the brute force approach? Let's think of a brute force approach. I found the difference of every element after sorting. I picked the minimum and I kept it. Like thinking of brute force is also like very confusing. Uh, then I did what? I found the difference of all the element with that. Closest element is always the better one. What is this? Okay. What is this? एक minute. What is say? Is it so? Is it always the case that in third, if k is greater than equals to 3, it will always be 0? Is it always the case? Since after performing an operation on the same pair ij twice. Oh, okay, right, exactly. I can like pick the same element. Why didn't this came to my mind? Why didn't this came to my mind? If like k is greater than equals to 3, I can always pick same element, add it, same element, add it. The difference will always be same, and then so if k is greater than equals to 3, answer is always 0. But if k is lesser than 3, it's like 2 or 1. So if it is 1, the two smallest element will give me. If it is 2, then only I need to check. So if it is 2, what I need to do? The smallest two element, pick the smallest two element, and then the smallest two element. Whatever the difference is, give it. Shit, yaar. It's like हाथ को आया मुंह को ना लगा kind of question these are. What's the name of the question? What it's saying? Boom. Nice. Okay, what's the first is test case is two values. It is something for If k is greater than or equals to 3, in that case I'll return to 0. uh, it's kind of first. So for the first time I will iterate if nums of I is lesser than second is equals to first, and first is equals to nums of else if nums of I is lesser than what second is equals to nums of I. Now if k is equals to 1, I'll simply return second minus first. If k is like 2, what I'll do is nums dot push back. There's one thing that I need to handle. Where are we expecting this? Hey, it's long. Long. It's 103. For first it is like 1, right? 3 minus 1, that is 2. Then 1 and 2. No, it's not really important. Why always like the minimum value? No, it should be the difference we are talking about. And if is equals to, let me start from mendif or nums of I. Else one oh three, 103. This is very huge, yaar. What? Why it's going negative? How much? 1, 2, 3, 4, 5, 6, 9. The values can be like 10 to the power 18. What is the maximum value of L long max? 1, 2, 3, 6, 9, 16, 19 होता है ये तो. Then it should be fine. nums of I minus 1 and nums of I. It is printing. Okay, this is 19. Oh shit. Yes, sorry. Oh, now I know. Okay, it has reached 23. On second, numbers differ. The answer is differing. The answer differs. Why? Mm-mm. It is a case when it is 2. For the third test case, it's 299500 for me. But the answer is saying 131. For 1 also? If is like 1, then the only thing that is possible is like the closest minimum. The array input is correct. There's no issue in array input. And the output, it is wrong. Let's do one thing. Why all? Why are? Why? It is something that I'm doing wrong. Obviously, my output is 299, but is saying 13121. What's the question? Just a second. I can use. Oh, okay, got it. Fine, bro, fine. Again. Hmm. One more case. Which other test cases are also failing? Let me. We have this one, two, three, four, fifth test case. Fifth test case. So one, two, three, four. Now for operation three times. 15, 3, 4, 5, 6, 16. 1, 2, 1, 5, 10. I'm doing only two operations, right? So this is 3. What is happening? 5 minus 2, that is 3. 2 minus 20, that is 18. 18 minus 20, that is 2. So this will be like 2. Then it is sufficient to find this. K is equals to 2 what? Why this K? I'm not able to get the intuition. K is equals to 1, it's fine. I found the minimum, that is totally correct. For K is equals to 2, what I'm doing is I found this D, right? Wow, hashtag define end as long long. So this is not end, this is long long. Great. I'm just thinking, why can't we do that? Whatever I am doing, why can't we do this? Uh, why this fails? If K is 1, I don't think there will be a problem. But when K is 2, K, when the minimum difference is Weird, huh? Let's brute force the first operation. If the newly created value is v, so this is my new value, then it is sufficient to find the smallest a of I, satisfying a of I greater than equals to v, and greatest a of I satisfying a of I lesser than equals to v, and relax the answer on a of I minus v. Also remember to consider the cases on performing no operation or one operation. Not getting when k operation is 2, why if it if like k is 2, why I am what else can be there? P is like simply finding inside array A. I have this value I'm finding in my array. Oh my god. This is something insane. Oh my god. What is like what is happening? All the logics are failing. My brain like it's like running so simple, but the questions are not that simple. And even it is like you need to understand what happened is there will be possibility that a number which is greater than the smallest that I found, but that value is making a difference. Insane, insane, insane. This is given array size is 10 to the power 3, so we can go for an square operation. I need this mini. It was like critical thinking. Was really an amazing critical thinking. J starts from zero. J is an I got two loops. I'll create the diff. Diff is like nums of I minus. Based on this diff, I need to find a value. This will be like this is how we do lower bound, right? Begin here. This will give me the closest value index. If closest value index is lesser than n, then diff is equals to minimum of diff comma. Sorry. This is like amazing critical thinking, dude. This is accepted. Oh God. Superb question. Superb. Okay. I'll be back in 10 minutes. Don't go anywhere. Yo, I'm back. Let's go. Okay, so this is something. Okay. Alia and permutation. Let's see what this question says. Uh, okay. Hopefully, I'll get any kind of intuition here. Okay. Alia has been given a hard problem. Okay, so you're giving me a hard problem. Okay. Unfortunately, she's too busy running for student council. Please solve this problem for her. Okay. Given an integer a, construct a permutation p of integers 1 to n that maximizes the value of k, which is initially 0. After the following process, perform n operations, and on the ith operation, if I is odd, k is equals to k and p of I, where and denotes the bitwise and operation. If I is even, k or p of I. For the first test case, the value of k is determined as follows: 0. Initially k is 0, correct. On the first operation, 1 is odd, so Ila sets k to be k and p, 0 and 2, which is 0, correct. On the second operation, 2 is even. Ila sets k to k or p of 2. P1 and P2. What is P2? Okay, okay. And somehow I need to maximize the answer. Let's see, I'll keep this array game. So like there might be like multiple. If there are multiple such permutation, output any. So if there possibly multiple such iterations I could see. Or operations are always going to increase the value, and operations I'll try to uh, keep my and while doing and operation I need to keep the value safe in the sense whatever value we have we can like do and with the same number if possible, else we'll do and with the number, mm, which will not affect change the answer, which will not reduce the answer. Another valid is 23145. What all things that are coming in my mind, if like k I need to maximize the k, right? I need to perform 5 operations, right? I need to shuffle any permutation possible. 3 4, it's like 1 2 3 4 5. 1 2 3 4 5. In first operation 1 is odd, so we will do and operation for this, and and so this will be fixed, right? And I need to keep maximizing my values. uh, we have and we try to keep values, bigger values on or operations. Maybe like if I keep 5 over here, will I be able to save? No. One 3 and 5, keep and numbers at same numbers at and. For or uh, what we could do is, if I exchange places, what will happen? And will give me 0 0, or 4 will give me 4 4 or 3, 4 and 3, kind of will reduce it down to 0. I didn't want that. The first number will always be a waste. Don't you think so? Keep 1. Even if I keep 1 in the first, my answer is like currently 0. I have R at second place, even. Like there are lots of possibilities. One way is like at one place keep all the values either from 1 to 5, then go to the next, and then place some other value, then go to next, then place some other value. Test every possible scenarios, and whichever will give you the maximum answer will be like the answer. But that'll be like a huge time complexity. And even if it can go like n square complexity. Mm-hmm. Now the array size is 10 to the power 5. I cannot go in square complexity. Bitwise and bitwise OR. What can we think? What can we think of? Doing AND operations and doing OR operations at the same time. Pre-calculate something pre-calculated, and pre-calculated and pre-calculated OR. Will that even make sense? If we like do pre-calculate, what will happen? Interesting. I need O of n solution or n log n solution, not more than that. So n log n solution will like generally will go for a binary search approach. Can I apply a binary search? See, somehow we are increasing the values. We are not reducing the values. If we are able to do that, if we somehow try to increase the value, See, let's take this as a like valid output. For the second test case, we have 1, 2, 3, 4, 5, and 6. Correct. Now this was odd. I did like let's see. Are we trying any? Are we getting anything from here? Leave it. 1, 2, 3, 4. Or maybe even leave it that. And or. My answer is currently 0. My answer is currently 0. What I'm saying is AND it with 2. What will happen? 0 answer. Or with 4. My answer will be 4. And with 1 it will become 0. Or with 6 it will become 6. And with 3 it will become 2. Or with 5 it will be 7, right? This is the permutation, this is the output 7. So it's not always the case that it is increasing. I'm going to take the same as 5, 2, 6, 1, 3, and 4. What will happen? 0. 2 with OR as 2, sorry. And with 6 will be 2 again. Or with 1 will be 3. And with 3 it will be 3. Or with 4 it will be 7. So this time there is like always an answer which is always increasing. There's always a possibility of like increasing increment. So maybe we can think in that direction. I should not reduce the value. Let's see if anything comes out with so we are given like 5, 1, 2, 3, 4, 5. Now what I want is I had to do and keep the answer as maximum. So I started with 0. I see and I don't want my answer to be reduced from 0. So I can place any value here. Okay, so let's place 1 only over there. Now OR comes. I need in OR I want to like increase the value while doing OR. So if I do OR Aryan Raj Rathwai John. Thank you. I didn't buy. आप भी जॉड हो. Hmm. If I do OR operation, what else possible is possible? Maybe I can keep 1 over here. That is the minimum value that I can increment. So if I keep 2 here, doesn't matter. Let's keep 1 over here to make the minimum increment. So I did the minimum increment. Now I need to sustain this minimum increment. For keeping this minimum increment, I need to have a number which has this value. So have we used 1? Yes. Now the next number which has 1 is like 3. Did we use 3? No. So I have to use 3. That will keep it sustained. Now the next is OR. The numbers left are 4 and 5, so I can like use 4, the minimum one. So that will give me like 5 as my answer. So I need to sustain this. I need to have 5 or a number which is more than that. So 5. Like this is also possible. Like but I'm not getting the exact way. If I keep 1, my answer will be like 0. I need to sustain, like, or if we come at OR place, let's try to increment. So just bigger value is 2. I need to sustain this. So for 2, keeping 2, what else can I add? 3. I can keep 3. So this will like keep 2 as my answer. I can keep 4 here. That will make 6 as my answer. And I need to sustain 6. That is, I need 7. I don't have 7, I have 5. That will be like 4, which is wrong. Not getting any kind of intuition. We can make k what it needs to be using at most the last 5 numbers of permutation. Every other element can be assigned randomly. We can split this up into several cases. Case 1, n is odd. The last operation will be bitwise and the bitwise and of k with the last element which is less than or equal to n is less than or equal to n. It is always possible to get the final key value equal to n. Let L be the lowest bit of n. We can set the last four numbers to be. After the first two, after the first two key will have is the one bit turned on. After the fourth one, weird, huh? These bitwise and or are always like a problem to me. This and I need to check this. It's like too much confusing. It's confusing me a lot. Uh, is there any other tutorial for this? What is this announcement? Mhm. Okay, this is like and or is confusing me a lot. Um, I need to check the tutorial for this. Maybe on YouTube. I'll try to look this question on YouTube if there is someone who posted this or not. Let me check it. Okay. Maybe I'll try to look. Okay, this is some insane logic. Good. But I did not understand it completely. Yeah, I did understood the logic that is said, but still. You're given an array A of size n. You will do the following process to calculate your penalty. Split array A into two, or possibly empty subsequences S and T, such that every element of A is either S or NT. For an array B of size m, define the penalty. Okay. I think I'll stop here. Uh, I need. I'll be back again tomorrow. I'll start from here. I'll be back again tomorrow. I will start more coding. It's like I'm little demotivated right now uh, because of the question and the way it's been solved. So I'll stop here and I'll take a break for some time and then I'll start coding again. Even though I will not be streaming. Do we have a contest today? Check. Yes, we have bi-weekly. So okay, I'll be giving the bi-weekly then, today and tomorrow also, and then I'll be back tomorrow with another live stream. So thank you all for watching. Hope you learned a lot. um Kind of irritated today I was, but still okay.